Hello everybody, today we will be going over a math sets problem at the IB Math Studies level. And so before jumping into the problem, we first have to see what is n, what is z, what is q, and what is r. Okay, n makes reference to natural numbers, okay? And natural numbers are going to be, in math terms, integers that are positive, okay? And so that means like numbers like 1, 2, 3, on to infinity, okay? It's very important that they are whole numbers, okay? So you're not going to have something like 1.5, okay? That would not be a natural number because it's not a whole number. Neither would be a fraction, all right? And so those are natural numbers, while integers are the same as natural numbers with 1, 2, 3, on to infinity, but additionally with 0 and the negative whole numbers, okay? So integers and natural numbers are very, very, very similar. Moving on, we have the rational numbers, which are the Q's. So rational numbers. And this makes reference to any number that can be written as a ratio, as a fraction. Okay, ratio and fraction, I'm going to use them as synonyms. And if you have trouble remembering this, notice that the rational numbers literally has the word ratio inside of it. Okay, and so this would mean numbers like 2 over 3, 4 over 7, but also numbers like 2, 5, and 9. Why would 2, 5, and 9 be included in this? Because 2 can be written as 2 over 1, 5 can be written as 5 over 1, and 9 can be written as 9 over 1, which would also make it a fraction, or in other words, a ratio. So that is one tricky thing that you have to watch out for. Okay, this also includes numbers like -4. -4 can be written as a ratio as well. It doesn't matter that it's negative. So those are the rational numbers. And last but not least, we have the real numbers. And the real numbers is really just a fancy way to say, hey, really any number from negative infinity to positive infinity. All real numbers are included. For the IB Math Studies level, you don't have to worry about imaginary numbers, but if you ever face here on this side something like plus I, then yeah, that would be an imaginary number, and here in the real section you would put no. But you're not going to face this, but it is also good to know that those numbers exist. So, moving on to how and what is the best way to solve this problem. I feel like you first want to go for the easy ones, right? The easiest one is the real numbers, and by the most part, you're going to be checking that all the numbers are indeed real. You will pretty much never face an imaginary number at the big math level, so don't worry about that. So that is the easiest column to solve. The next easiest, I feel, would be the natural numbers and the integers, right? And now that we already got familiar with them, we notice that the natural numbers and the integers are very, very, very similar, right? Um, because the integers have the natural numbers inside of them. And so this can be a very easy way to approach the problem. So looking at 42, for example, it's a whole number and it's positive, so it has to be a natural number. And if it's a natural number, then that means it's also an integer. So that's a very quick and easy way to solve it. Here, we do not have a whole number because we're dealing with a decimal. And so we will not have natural or integer. So I'm not even going to fill it in, but I will put, I will mark it as an X just to let you guys know. This is not a fraction either. Sorry, this is not a whole number either. If I were dealing with a number like square root of 16, which simplifies to 4, then that is different. Okay, so watch out for those traps. Sometimes they can do. Or numbers like square root of 25. If you're not sure which of these are whole numbers or not, you can always check with your calculator, so I recommend you to do that. If I pop square root of 23 into my calculator, I'm not going to get a whole number, and so this would not be a natural or an integer for that matter. Moving on, negative 113. First things first, it's a negative, so it's not going to be a natural number, bada bing, bada boom, but is it an integer? It is an integer because we're dealing with a whole number. Negative 113 can be written as negative 113 over 1. These numbers are the same, so this would be an integer. 24 over 6, we see if we can simplify it in any way, and this actually simplifies to 4. You can check this with your calculator, and so if it's a natural number, it is also an integer. So bada bim bada boom, that is how you do that one. And last but not least, -5 with part 1/5. It's negative, so it's not going to be natural, and it's a fraction, so it's not going to be an integer. Bada bim bada boom, we are done with the first two columns. We are also done with the real numbers, because that is the fastest way to do it. And now we are left with only the rational numbers. And honestly, when we're dealing with number sets, this is where people get really confused. Okay, the rational numbers is where things get tricky, out of control. And so I feel like a good approach to these problems is making sure that you get, the natural column correct, the integer column correct, and the real number correct. And then, it's more likely to mess up with the q. But with the other ones, you can nail them. And at least in this column, you can like try guessing, and there's a solid chance that you're gonna get most of them right. So I feel like this is the best approach to the number set problems. Okay, and so we have to basically ask ourselves with the q's, can it be written as a ratio? Okay, that's the most important part. Can it be written as a fraction? And so 42 over 1 is the same as 42, and 42 over 1 is a fraction, and so it can be written as a rational number. 3.14, can it be written as a fraction or as a ratio? And the answer is yes. 3.14, and this is the trickiest one, I think, can be written as 314 divided by 100. And this would be indeed a rational number or a fraction, so that would work. Okay, so for this part, 3.14 is indeed a rational number. What I think they were trying to trick us with, because that is how the examiners are, they try to trick you with thinking that this might be pi. Okay, if this instead were pi, then it would not be a rational number, because the number pi, which is 3.141, and an endless series of numbers, cannot be written as a fraction, right? Um, and so that is maybe what they were trying to trick you with, you know? Putting 3.14 might remind you of pi, but it's not actually pi, okay? And so that is an important distinction and a very common mistake that is committed. Moving on, with square root of 23, we have to check if it's a never-ending series of numbers or not. And if we go to our calculator, we can see that square root 23 is 4.79588315, blah, 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 up until infinity. And so this would not be a rational number either, because you cannot express it as a fraction, right? And so here it would be a big fat X. Square root 23 cannot be written as a rational number, and by the most part, and this could be a good rule of thumb, square roots are usually not going to be rational numbers, but you do have to check if you can simplify them. As I said earlier, for example, square root 36, you might say, oh, it's a square root, so it's not going to be a rational number. But if you simplify it, you're going to notice that it is 6, and that would be a rational number. Okay, so careful with that. So here we would put a big fat X. For negative 113, you can express this as a fraction because, as I said earlier, you can put a divided by 1 over here. 24 over 6 gives you 4, and you can put 4 over 1, so that makes it a fraction or a ratio, a rational number. Good to go. And last but not least, this number here is also a fraction or a rational number, and you can literally see that it is just visually. And so that is how you solve this problem. I feel like, just to leave it really clear, the most important part is to understand, well, what n, what z, what q, and what r is. But more importantly, the approach, you want to do the easy ones first. Be easy on yourself. Do n, do z, do the real numbers, and then do the challenging one. And worst case scenario, you can just flip a coin and maybe you get it right. Okay, but this is the best way, your best odds at getting the maximum amount of points in this problem. So that is how you solve this, and I hope it helped. Peace out.